In this video, we're going to look at different ways that electricity is generated. So, by the end of this video, you will be able to distinguish between renewable and non renewable energy. You'll be able to explain how different types of both renewable and non renewable energy can generate electricity. And finally, you'll look at some of the advantages and disadvantages of different sources of power. So let's get right into it by taking a look first at how electricity is generated generally. And so when we take a look at electricity generation, there are lots of different ways that we can create energy. So we have our fossil fuels, which are coal, oil, or gas. We also have nuclear, and then we also have some other sources. So hydro or waves, solar, and wind. So, regardless of what kind of type of energy source we have, all of the different ways to generate electricity go through the same sort of mechanism. First off, they will turn what we call a turbine. And so this is basically a big giant rotary blade that is turned, and by turning it, it will give basically the generator power in order to be able to transform the energy from the motion of the turbine into electricity. So the general path is we will turn this turbine and then it will go through a generator, and then goes then to a transformer, and then we'll go out through what we call transmission lines to cities and towns, and that's how we get electricity in our homes. Now, in terms of Ontario and the methods that we use to generate electricity, the majority of our electricity is generated through nuclear energy. Next, the most popular way is through gas. And so, gas and oil, this is our fossil fuels. And then hydro is next, followed by wind, biofuel, and solar. And they are in much smaller quantities. Now, like I said, there are many different ways to be able to turn that turbine in order to generate electricity. The first way is we can use water to generate electricity. And so, what we're doing here is we're using the power of flowing water in order to be able to turn the turbine. So, these power stations will use fast flowing rivers or waterfalls to turn their turbines. And so, what we have is we have water up at the top here and a dam, and then the water will come through the dam down through this path here, which then will turn our turbine, and the rest of the water kind of flows out through there. So we're using that power of the water going from up here down to here to turn our turbine, which then goes to a generator, through a transformer, and then out through our transmission lines. And so a good amount of water is generated. We generate electricity in good amounts from water in Canada. Niagara Falls is a great example. Down there, they have a very large power station. Another way that we can generate electricity is through heat. And so this is mainly done through fossil fuels such as coal, oil, or natural gas. And so, this example here in this picture, we see the coal arriving to these power plants by train or through truck. The coal is then put into a furnace, and the furnace heats up water and turns it into steam. And so the steam is what turns the turbine. So it comes through the turbine, it turns the turbine, which then goes to a generator, to a transformer, and then eventually through transmission lines. And the water then is recycled, or the steam's recycled from the turbine. It'll go up through into cooling towers, cools back down again into liquid form, and then goes back into the boiler to be turned back into steam again. And so this is, probably one of the most popular ways that we generate electricity in Ontario. Now, there are other forms of electricity generation as well. And we're just going to kind of take a quick look at some of those and how they end up turning the turbine. So, the first is nuclear energy. Like I said, this is the most abundant way of how we generate electricity here in Ontario. And so nuclear energy uses the reactions of nuclear fission. So what happens here is that a element, usually uranium, is basically broken down into its neutrons, so those are released, as well as a lighter element. So it's basically fission means to break it down, and by doing that it releases a lot of energy. So the energy released is used to heat water, similar to the coal power plant that we just took a look at, and that produces steam to then turn a turbine. So it's really just the process of getting that energy with nuclear energy that's a bit different. Geothermal energy is an interesting one. And so this can only take place in certain areas where underneath the Earth's surface, really far down, there is naturally hot rock down here, deep in the Earth's crust. And so you can use this hot rock down here to pull through water, which will then heat up the water, goes up, creates steam, turns the turbine, which goes to the generator, goes to the transmission lines, and then the water gets recycled back. So from steam through cooling towers back down into the earth again. Solar energy is a great one. So you can use the energy from the sun and convert it into electricity itself. Um, Usually, we use these solar panels. You'll see them on a lot of homes, and the solar panels will then collect the energy from the sun. They use an inverter, which is basically kind of like a transformer, which will then turn that into useful electricity. And then it also can be connected back through transmission lines as well. Wind energy uses the power of wind. So we create these wind turbines that have blades which are rotated by the wind. So this is a little bit different from all the other ones that use steam. This is directly using the wind, which is going to rotate these turbines. And then the turbines are connected to a generator, which is then connected to a transformer and finally to the transmission lines. And then we also have tidal energy. So this is kind of similar to the hydroelectricity, except we're using the power of the tides coming in and out. There's a really big power plant in the Bay of Fundy because you get quite a large difference between the tides coming in and out in this location. But basically, the turbines are turned as the tide comes in and as the tide goes back out. And these are bidirectional. So it means that they can go in both directions depending on whether the tide's coming in or the tide's coming out. Okay, that's it for this video then. Let's move on to our next task.